упадет, если головой не трясти.
У нас онлайн-трансляция, когда, соответственно, если будут какие-то вопросы из зала, то желательно, чтобы микрофончик задавал. Сможете это делать? Да, конечно. Сейчас, на самом деле, до 20 метров, но
Who is next? Yeah, there are 7 more.
Ребята боятся. Только не ударят.
Come on, you. Let's see what she's thinking. Okay, we have another volunteer. And from the second row, one of you. You have to try that. Good. I always carry this, but just to show it, never to do the real test like you are doing. Good experiment. You know, in Malaysia, they bought 1 million of those to use in elementary schools.
Really?
To see if the children could add and subtract, because if you say 2 plus 2, then you think 4, and it detects if you're thinking 4 or 5.
Okay.
So they bought, yeah.
Millions?
Well, I think it was like 1 million, yeah.
Really? In Malaysia?
Yeah, yeah.
Wow.
Well, right now they are only like about, I think, $70.
Yeah. Oh, yeah, I don't know how much it was maybe 100.
And when it began, it was $1,000. Then it went down to.
Oh, really? No, it wasn't like that.
I think the first one.
Good evening, Jose. My name is Vladimir, and
Oh.
this is Alexei from the
Oh.
Libertarian Party.
Oh, a pleasure, a
Pleasure
pleasure.
to meet you. A pleasure to meet you as well, and we'll talk later a little bit about tomorrow, okay?
Yeah, fantastic.
Afterwards.
Fantastic.
All
Yes, but you are staying here.
Yeah, we're staying here for the lecture.
Good, good, good. So, yeah, I always show that. And I had one of the emotive
Yeah,
with 14
emotive.
electrons.
Yeah, emotive is expensive, but
Yeah. No, but the first one, when it came out, like it was in 2008, it was $999.
Really?
Oh. Yeah, yeah. And then it went quickly down because only one electrode, it went down to $150, $99, and now it is $70.
Like that.
There are 4 more. We need 4 more volunteers. Good, good. Don't be afraid. Nothing bad will happen. Actually, something good. We will discover if you have a brain and if it is working. We're getting close to the.
Yeah.
To the
You have to start it. Ты сломался?
she has a complicated brain. That's the problem with women. Their brains are very complex. Oh, what happened? You have a very complicated brain.
Okay, I think we have to start now, since we are announced online as well. So, I'd like to introduce you Hose Cordeyro. Some of you probably last year were actually attending his sessions with High School of Systems Engineering at Moscow Institute of Physics and Technology. So he's our friend. He's trying to every year to give a presentation for our students in Fistech. And this time he's we schedule of the campus visits is not corresponding with schedule of Jose, but today we are here, and some of our students are online watching the presentation. And Jose is the professor of Singularity University, and this is one quite new, very interesting educational foundation. And today we will have a presentation about the future of energy and the energy of the future. Energularity, or how do you call it? Or
Energularity.
Energularity, okay. Energularity. So please, Hose Cordeyro.
Okay, well, thank you so much, Greg, for the invitation to talk a little bit about the future. So I have a long presentation divided in two parts. The first part is more general about the future and about the singularity. And the second part is about the energularity, which is what I call the energy singularity that we are going to see in the next few years. I work with different futurist organizations, like the Millennium Project that began as the futuristic part of the United Nations. I am one of the founding professors of Singularity University, and I also work in Tokyo as a research fellow at the Institute of Developing Economies.
You have your microphone already.
Thank you.
For the audience.
Thank you. Yeah, I was using then two microphones, not one. Okay, and then...
just a second. If somebody wants to ask a question, just feel free. I'll give you a microphone.
Okay, I am originally from Venezuela. I don't know if you know what Venezuela means. Venezuela means Piccola Venezia, because Christopher Columbus on the third trip, he arrived there and he saw that the Aboriginal people, and like Venice, and Venezuela is very famous for beautiful women. We have the record of Miss Universe, Miss World, and Miss International. So anyway, with the Millennium Project, we have people thinking about future issues around the world, including here in Moscow as well. And we consider the 15 global challenges that we publish every year in a book called The State of the Future. Additionally, as I mentioned, I am one of the founding faculty of Singularity University that began in 2009 with the support of NASA and Google. And there we study exponential technologies in general. The idea of the singularity has become very popular, that even Time magazine wrote a whole issue about the singularity, and they took the year 2045, which is the late year when we expect the singularity to happen, so that people didn't get scared, because probably this could be in the year 2029, but at the latest in 2045. And one of the incredible consequences is the year man becomes immortal. But for ladies here, women will also become immortal, so do not worry. The idea was popularized by Ray Kurzweil 10 years ago when he published the book The Singularity is Near, that is recommended by Bill Gates as the best book about the future of humanity. And now, actually, Ray Kurzweil is working on a new book. He's finishing writing a new book called The Singularity is Nearer. So it is becoming even closer now. Many of the things about the idea of the singularity have to do with Moore's law. Gordon Moore was one of the founders of Intel, and he discovered that computers doubled their power every 2 years and that the price was reduced by half every 2 years. Now this is actually accelerating. If you look at this, this is a logarithmic scale, which means an exponential change, but it's becoming faster and faster. Right now, computers double their power every year and a half. And soon, when we have three-dimensional circuits, this could be maybe every year. So depending on how fast this goes, between 2029 and 2045, we are going to have computers that have more transistors than our brains have neurons. And that will be the beginning of the singularity, which many people define as the time when artificial intelligence reaches human intelligence level. And that will be the last invention that we humans will make. Because once we have an artificial intelligence as we are, there is nothing that we will invent before it does it, unless we merge with the technology. And this is what we believe will happen. We will fuse with the technology. So that you do not sleep tonight, actually this is very scary, because this is really the end of the human age as we know it, the end of the human age and the beginning of the post-human age of humans who have been enhanced with technology. You are very young and you might not remember or know how technology has evolved, but 30 years ago when I was a student in university, this is what we used for computer memory and for programming. These are the punch cards, and this is basically 10 rows times 100 columns. And that is 1,000. This is 1K of memory we used 30 years ago. And we had to make holes all the time. That is what we did in computing science. And so these mechanical memories could not be changed either. They could not be erased once you made the holes. So the first electromagnetic memories were invented. And I have an example here of the first generation. This is also 1K. But this 1K was better because you could erase. It was also better because it had a bigger hole. Okay, but it was also 1K, one electromagnetic and one mechanic. So in Spanish, we call this K, not K, K is K. So this is 1K plus 1K. So how much is 1K plus 1K? It's not 2 Ks, it's 1 kk. 1 kk. We had 1 kk of memory 30 years ago. And this kept on evolving. As you probably remember, these were 5¼ inches big, and this had 512 kkas. And then this one, which is 1.4 mega. And now I have a pen drive here, which is 128 gigas. 128 gigas. So look at the incredible advances we have had. And I don't know where I left my pen drive. But it is 128 gigas, okay? So imagine what has happened in 30 years. We went from 1 kk to 128 gigas. So you will remember me in the next 30 years because this continues, and this continues exponentially. So in 30 years, we will actually have devices that have more transistors than you have neurons in your brains. And that is the beginning of the technological singularity. So this will not be, I'm still looking for my 128 gigabyte memory. So I don't know if this is it. Oh, okay, this is one, yeah. So imagine what has changed in 30 years. So what we will see in the next 30 years is even more incredible. And this is happening in all technologies, all different types of devices, all types of memories, but also in other areas like biotechnology. And I want to show you the sequence of my human genome, the partial sequence of my human genome. This is done by a company called 23andMe, and you can see this is my name, Hose Kordeyro. So my genome is in internet, actually. And you can see what my genes are and which diseases I will have. What is the probability of me having psoriasis, diabetes, prostate cancer, and other things that I don't want to show, Alzheimer's, Parkinson's, etc. But once you sequence your genome with a little device like this is called a gene chip to sequence the genome, you will know what you will die of in the future. Isn't it interesting? But the idea is that you do not die of that, because once you know what you will have, you will actually have a medicine to prevent it. Medicine in the future will no longer be curative, it will be preventive. You will also discover where you come from. This is my paternal line, 500 years ago. You can see from my father's side, my ancestors come from Spain all the way to Asia, to Mongolia. And you will also see then famous people related to my father, Genghis Khan. So I descend from my father's side from Genghis Khan. So no one wants to fight here with me. And I will show you now my mother's ancestors. Famous people related to my mother, Marie Antoinette. So I come from a very aristocratic family between Marie Antoinette and Genghis Khan. All of you will know where do you come from once you sequence your genome in the next 5 to 10 years. And you will be able to reconstruct your genealogical tree and verify for the first time if your father is really your father. But more interesting than looking backwards is looking forward. And in the future, we will design the children the way we want them. This is an experiment I did with one of my students, sharing genes. Obviously, this is a theoretical experiment to see how the children could be once we share the genes, and what is the probability, and then select those genes. Actually, this will be a standard in 10 years. We will design our children the way we want. You are part of the last human generation that is here by mistake. All of you are here by mistake because you were not designed. In the future, you will be designed with the characteristics that your parents want. So there are 4 technologies that are changing humanity. And more than humanity, they are changing humans. They are nanotechnology that studies atoms and molecules, biotechnology that studies cells and genes, infotechnology that studies bits and bytes, and cognotechnology or cognitive science that studies neurons, the brain. All those technologies are converging in the next 20 years through this technological singularity, and they will change humans. The 2 technologies on top, nano and bio, are what I call the hardware of life. The hardware of life. And the 2 technologies on the bottom are the software of life. And in the next 20 years, plus minus 5 years, plus minus maybe 10 years, we are going to reach the complexity of the human hardware and the complexity of the human software. And once we reach that complexity, we will go beyond it. We will improve on the human hardware and the human software. There are 2 numbers that you need to know about the complexity of the hardware and of the software. For the hardware, the genome actually is what is important. We have 3 gigabytes of data. Human beings, Homo sapiens sapiens, we have a bit less than 25,000 genes, which are expressed in 3 gigabytes of data. If you remember biology, there are 4 nucleotides, A that goes with T and C that goes with G. 15 years ago, one scientist created the first artificial virus. But viruses are simple, are small. 5 years ago, another scientist created the first artificial bacteria. Actually, he's a very famous scientist called Craig Venter, who also has given lectures at Singularity University, and he created the first artificial bacteria 5 years ago. And to prove that he created the bacteria, he inserted his email in the genetic code of the bacteria. So this is the first bacteria in history that has no father bacteria, no mother bacteria, but that has email. So this was done 15 years ago, a virus, 5 years ago, a bacteria. How long do you think until we make a human being, or we enhanced a human being? This pen drive I was telling you is 128 gigabytes. And how much is the human genome? 3 gigabytes. So how many people can I put in here? So how much is 128 gigabytes divided by 3 gigabytes? 42.666 people would fit here. I can put the genome of 42 Russians and 1 little Ukrainian. That's a bad joke. I have many bad jokes. So. Okay, one little cat. So this is the complexity of the human genome. Now that corresponds to the human hardware. Now I will show you the complexity of the human software. And first of all, the cost. How much does it cost to sequence the human genome? The first human genome began in 1990 and it finished in 2003. The Human Genome Project took 13 years and it cost $1 billion to the US government alone. Today, you can sequence your complete genome for $1,000 in 1 week. We expect that in 10 years, you will sequence your whole genome for $10 in 1 minute. This is truly incredible exponential, both in cost, going down from $1 billion to $10, and in time, from 13 years to 1 minute. So that is why all of you will sequence your genome in the next 5 to 10 years. Everybody will sequence their genome, because it will be very, very cheap. Now let me show you then the complexity of the human software, which is the brain, the processing power of the brain, which is the most complex structure in the known universe. There is nothing that we know today that is more complex than the human brain. Maybe tomorrow there is a Martian that arrives here, the Martian, and has a more complex brain than we do. But until that time, there is nothing that we know in the universe more complex than our brain. And our brain really is not that complex. Our brain has 10 to the 11 neurons, which is 100,000 million or 100 billion neurons. Each neuron has about 1,000 connections called synapses. So that makes 10 to the 14 synapses. And the synapses are the ones that compute. The human brain has 6 major frequencies: alpha waves, beta waves, gamma waves, mu waves, etc. And they are very slow. The frequencies of our brain are normally 1 hertz, 1 revolution per second, 10 hertz, 100 hertz. That is how fast or how slow our brains are. I have a very fast brain of 1 kilohertz, or as I call it, 1 kakahertz. I have 1 kakahertz brain. But if you take your mobile phone, any device today, any electronic device has at least 1 gigahertz, at least. So your mobile telephone is 1,000,000 times faster than your brain. The difference, obviously, is that our brain still has more neurons than this has transistors. But that will change in the next 20 years, plus minus 10 years. We will have soon computer electronics that have more transistors than we have neurons in our brain. And that will be the beginning of the technological singularity. So basically, a brain is a machine that computes 10 to the 17 operations per second. And that is if we don't talk about the mind, the spirit, and the soul. I love to talk about the mind, the spirit of the soul, but only after 3 shots of vodka, so that you can really begin talking about the spirit. Okay, so this is the complexity of the most complex structure in the universe, our brain. Only 10 to the 17 operations per second. And I repeat, we are going to get to that level of complexity in 2 decades. And then, actually, there are smaller brains as well. There are no bigger brains, but there could be smaller brains. And now scientists are connecting brains to brains. There is a couple of scientists in the USA working on brain-to-brain communication between mice, and there are 2 other scientists working on brain-to-brain communication between monkeys. This will be common in the future. Actually, some of you have devices like this, Mind Wave by NeuroSky, which I like to show, because this is basically just one electrode here that goes in the frontal lobe that captures what is happening in the frontal part of your brain, and it has a Bluetooth connection that sends the information to a computer. So this is reading part of what is happening in your brain. Now there are devices like Emotive that have 14 electrodes, and there are other newer devices that have 50 electrodes. Soon we will be able to capture almost everything that happens in your brain and transmit it to another computer or to another brain in the future. This is the beginning of telepathy. We will be able to communicate telepathically in the future. And this will be very efficient, because talking is a primitive technology. This is what I call a caca technology also. Talking is very inefficient, very slow, narrow bandwidth, and unidirectional. While telepathy is basically what computers do. You know, they communicate very fast with broad bandwidth. This presentation in the future will finish in 3 seconds. In the first second, I send you from my brain to your brain the presentation. High speed, broad bandwidth, in 1 second. In the second second, you ask any questions you want. And on the third second, we all go out and drink some vodka to talk about the spirit. Okay, so this is for you not to laugh, but to really think that telepathy is possible, and we will be communicated through telepathic means probably in 2 decades. And we will connect to the robots, actually. We will use this to connect with robots and cyborgs. These are the last 15 years of the robot Asimo by Honda. Can you imagine the next 15 years? Can you imagine it? Well, in 15 years, the robots will be more human than humans. Actually, Honda says that in 20 years, they plan to win the Football World Cup. The Football World Cup. So if Russia doesn't hurry up, it will no longer win the Football World Cup unless it is a Russian robot team. Because these robots will be incredible. They have, for example, 360 degrees of mobility. They can turn their heads completely on each direction. Does anyone want to try it here? And they will have feelings. In my alma mater, MIT, the Massachusetts Institute of Technology Media Lab, there is a group of scientists working on understanding the feelings of robots. Robots will have feelings. And something even more incredible. In the National Assembly of Korea, South Korea, they are working on a law to give human rights to robots. Human rights to robots. In the Congress in Korea. I don't know what is being discussed in the Congress here in Moscow, but I can tell you that in Korea they are talking about human rights to robots. And these robots will be fantastic. Look at those incredible robots. And for the ladies, no problem. You will have your fantastic macho robot as well, with an additional advantage: they will not get tired at night. Unfortunately, in the Western mentality, robots are bad. We think robots are bad because the word robot comes from Czech. It's a Czech word that means slave labor. So we think robots are bad because of the Czechs and because of Hollywood. In fact, even female robots are bad. And even when they have robot sex, they are bad. But are robots good or are robots bad? It depends on where you are born. If you are born in California, in the Czech Republic, I don't know here, you will probably think that robots are bad. But if you are born in Japan robots are actually good. All children in Japan grow knowing that robots are good. Last year, one of the best-selling books in Japan was How to Make Love with a Robot. So even if you are afraid of robots here, in Japan they want to have sex with robots. And I will tell you something, at least it will be cleaner. Additionally, let me tell you why robots are so bad, because we think of Terminator. You know Terminator, the actor Arnold Schwarzenegger. After he did Terminator 3, he went into politics, and he was elected governor of California, or as we call him in California, the governator. Arnold Schwarzenegger inaugurated Singularity University in 2009. He gave a speech opening the university in 2009 when he was governor of California. And he said he was very happy that there was an institution preparing humanity for the future, because the science fiction of today is the science reality of tomorrow. And he finished his talk with his very famous phrase, "I'll be back." And now that he's not governor anymore, he actually made a new movie, Terminator 5, Genesis. Has anyone seen it, Terminator 5? Because it happens in the year when the singularity begins. So be ready about the future. Okay, so robots, we think we are bad here, but they are good in Asia. I'll give you an example so that you understand. Dragons. Dragons are bad here, right? Dragons destroy cities, eat people, throw fire, right? But where are dragons good? In China, in Japan, in Korea. Dragons are so good in China that they are the symbol of the Emperor of China. So you might think that they are bad, dragons, like you think robots are bad, but robots and dragons are good in China, in Japan, in Korea. So in Japan, they always grow thinking about robots, and robots being even better than humans. So all these technologies are changing exponentially, faster, smaller, cheaper, and better. And we don't understand exponential change, because we evolved in a linear world, and our brains think linearly. But exponential change is very different from linear change. The typical example is that if I walk 30 linear steps, each step of 1 meter, after 30 steps I have walked 30 meters, right? But what happens if I walk exponentially, where each step is the double of the previous? After 30 exponential steps, 1 meter, 2 meters, 4 meters, 8, 16, 32, 64, 128, 256, and so on and so forth. After 30 exponential steps, I have walked more than 1 billion meters, and I have walked around the Earth 26 times. Can anyone understand that? We don't understand exponential change because our brains think linearly. 10 years ago, I went to visit a very famous science fiction author, Sir Arthur C. Clarke, who actually was an electric engineer, but he was more famous for writing science fiction books than being an engineer. And he's famous for movies and books like Space Odyssey 2001, but also because of the laws of the future that he wrote half a century ago in the 1960s. He said, first law of the future, when a famous scientist says that something is possible, he's probably right. But when he says it is impossible, he is probably wrong. Second law of the future. The only way of discovering the limits of the possible is to venture past those limits into the impossible. And third law. Any sufficiently advanced technology is indistinguishable from magic. This has a corollary. If you see a technology that doesn't look like magic, it's because it is not advanced. So the technologies of the future are going to look like magic. Let's see what has happened in the last few years. 30 years ago, personal computers were just beginning. When I did my first thesis at MIT, my bachelor's thesis at MIT, I used a primitive technology called typewriter. I don't know if you have seen those caca technologies of the past, typewriters. Those were used until about 3 decades ago. 20 years ago, mobile phones were beginning, growing very fast. 10 years ago, companies like Google, Facebook, etc. were expanding. So what is going to happen in the next 10 years, 20 years, 30 years? We are going to see magic. And if the technologies do not look like magic, it's because they are not advanced. One of those technologies is the control of aging. One of our professors at Singularity University says that aging is a disease, but it is a curable disease that we are going to cure in the next 2 to 3 decades. For that, he created a foundation called, very appropriately, the Methuselah Foundation. If you remember, Methuselah lived 1,000 years. And so the scientists are working on a prize, which is the M prize, the Methuselah Mouse Prize, because they are making experiments with a little mouse. Why a mouse? Because a mouse is very similar to a human. When you sequence your genome, you will discover that you are 90% mouse, and you are 99% monkey. We are just 1% different from a chimpanzee. So if someone calls you monkey, no problem. You say, and you are a monkey too. We are all here monkeys, 99% monkey and 90% mouse. 90% like our ancestor Mickey Mouse. So anyway, in this prize, in the last 10 years, they have longevity and rejuvenation prizes. And look at what they have been able to do. Extend the life of mice 3 times. A mouse normally lives 1.5 years, 2 years maximum. Right now, we have mice that live 5 years. This is the equivalent of 300 human years. And 300 human years in perfect condition. These are not mice that are paraplegic in wheelchairs. These are mice having sex at age 280. Also with fruit flies, like the Drosophila melanogaster, the life has been extended 4 times. And with worms, 6 times. Actually, there are some Russian scientists working on this, both here in Russia and in the USA, in terms of longevity extension, because these are incredible advances in the last 10 years. Today, actually, we know that there are 2 types of cells that do not age. Germinal cells do not age, and cancer cells do not age either. And this was not known, last century, only was discovered later, that germinal cells, the ones that make a sperm in men and eggs in women, they do not age. However, when the person dies, germinal cells die with the person because there is no more food. The person dies and they die. But they do not age. And that is the difference between immortality and not aging. Because I believe we will control aging in the next 20 to 30 years. But that doesn't mean we will be completely immortal. Because if a piano falls on my head, I will be pianized, even if I don't age, right? But we will be able to control the aging process between 20 and 30 years, we believe. And the proof is that germinal cells do not age. You can extract your germinal cells today and keep them forever. Obviously, if you give it, food and water so that they keep on surviving. But the most interesting disease to me is cancer, because cancer also discovered how not to age. And that is what is so fascinating about cancer. Cancer is a mutation of a cell that ages into a cell that does not age. And that is why cancer has to be killed, because cancer does not die by itself. Cancer does not age. Cancer grows, cancer reproduces, grows, reproduces, and does not age, and does not die. So we need to kill cancer in order to save the person. So the proof that immortality is possible is cancer, because cancer discovered how not to age. So if cancer is stupid and discovered it, imagine, we think we are intelligent, right? So we should discover what cancer did, especially now that we can sequence the genome, because now scientists are working on seeing cancer cells and non-cancer cells in the same person and find those mutations. In the next 10 years, we are going to see Nobel Prizes in medicine done by engineers, because this is a statistical problem. Understanding cancer is a statistical problem. So much that now companies like Google believe that we will be able to solve death. We are going to solve death in the next 30 years. We are going to see the death of death. For those who do not want to die. I mean, this is not mandatory. If someone wants to die, no problem, die. But most people will decide not to age and not to die. And as Google has invested already $1.5 billion on the first phases of curing aging. Because now this is becoming popular and people are believing that this will be possible. And I repeat, because the proof of concept that this is possible is cancer itself. That there has been created a Nobel Prize for Immortality. A medical doctor, billionaire in California, has created the Palo Alto Longevity Prize, which is $1 million prize for the scientists who advance research towards immortality. So we are going to see incredible things in the next 20 to 30 years. You are part of the first human immortal generation. Obviously, if you behave well. If you live long enough to live forever during the next 20 to 30 years. Okay, now let's move into energy. Why energy? Because this is the largest industry in the planet. There is no industry that compares to energy. And everything needs energy, okay? And if you look at country by country by country, which are the largest companies in each country? Energy companies. If you look at Russia, you have companies like Gazprom, Lukoil, Rosneft, and many other energy companies. If you look at England, they have British Petroleum. If you look at the Netherlands, you have Shell. If you look at the USA, you have ExxonMobil, and so on and so forth. The largest industries in most countries are energy companies. So this is the largest industry in the planet, and it's going to be totally disrupted in the next 20 years. In the next 20 years, we will have a new energy matrix. As you can see, also it has to do a lot with geopolitics. This is another bad joke, but with the Bush family that are both working in the oil industry, using the oil companies, we shall not exonerate Saddam Hussein for his action. We will mobilize to meet his threat to the vital interest in the Persian Gulf until an amicable solution is reached. Our best strategy is to be prepared. Failing that, we are coming to kick your ass. Okay, this is just to tell you that not only is this the biggest industry in the planet, it is very geopolitically minded. In the USA, in Saudi Arabia, in Russia, in my original country, Venezuela. The National Academy of Engineering of the USA studied which are the global challenges of humanity. And the number one challenge is make solar energy economical. This study was led by Larry Page and Ray Kurzweil, who is the co-founder of Singularity University. And both Larry Page and Ray Kurzweil, they believe that by 2030, we will be using mostly renewables in the planet, solar energy and wind energy, mostly. Why? Because they are growing exponentially. And this is the link between the comments before. Energy, renewable energy is growing exponentially. Even Bill Gates, in his notes, yearly notes, he's talking about the importance of energy and how we are going to have solar energy. My alma mater, MIT, they created 10 years ago what is called the MIT Energy Initiative. And all the students at MIT have to take at least one course on energy. In any class, in philosophy, in architecture, in economics, every student has to take at least one course on energy. Why? Not only because it is the biggest industry in the planet, but because everything needs energy. We need to understand more about energy. And the person who created the MIT Energy Initiative today is the Secretary of Energy of the USA. Companies are also trying to see what comes next with energy. As you might remember, BP changed its logo and also even its name. It's not really any more British Petroleum. Now they like to call themselves Beyond Petroleum, because they are no longer British and because they are no longer just petroleum. Beyond Petroleum. I'll give you an example of my own country. This is the oil company of Venezuela that none of you knew, I'm pretty sure, but this is Petróleos de Venezuela Sociedad Anónima. None of you knew it, but all of you know Mickey Mouse, right? And I like to compare the oil company in my country with Mickey Mouse, because I like Mickey Mouse, as you can see my tie. But why? Because Mickey Mouse sells more than the oil industry of Venezuela. A little mouse, well, Walt Disney, sells as much as all the petroleum from Venezuela. And I'll tell you why, because Mickey Mouse is an example of the manufacturing, while oil is manufacturing, the past. I'll explain why with a Mickey Mouse hat. This Mickey Mouse hat is made completely of petroleum, probably Venezuelan petroleum or maybe Russian petroleum. The plastic comes from petroleum of the ears, the synthetic fiber comes from petroleum, the acrylic paint comes from petroleum. Also, my polyester tie comes from petroleum. I am wearing a lot of petroleum here. If you go to Walt Disney and you buy a Mickey Mouse hat, how many dollars do you think is a Mickey Mouse hat? How many dollars? 5, 10? No, who gives more than 10? 13? 30. Wonderful. Sold to you. Actually, it's between $1 and $30. It all depends on the size of the ears. Who said $1 bought really, really tiny Mickey Mouse ears. Who said 30, big, big ears, okay? This is an average Mickey Mouse hat of $10. Or as the Americans say, $9.99. $9.99. And it's made of petroleum completely. A barrel of oil is this big, a barrel of oil. How much is a barrel of oil today? 44, let's say 50, a round number, and be positive. $50, okay? And how many Mickey Mouse hats do you think you make from a barrel of oil? 1,000. Let's say 1,000 hats times $10 each hat makes $10,000. And the barrel of oil is 50. Where is the business? Is the business in oil or in Mickey Mouse hats or in Mickey Mouse ties? The business is in manufacturing, adding value. We need to add value to all resources. We have also seen since the end of the 18th century, beginning of the 19th century, how there is different energy waves. We moved from lumber, from trees, to coal, to oil, to gas. And if you look, each one of these waves is happening faster and faster. We are moving now from oil to natural gas to new energy sources in the next 20 years. Shell actually made some scenarios to the year 2060, including a lot of solar, geothermal, and even surprise energy. No one knows what that is, but we might have a surprise energy in the next few years as well. How much oil do we have on the planet? So far, we have produced 1,000 billion barrels of oil. This is what we have produced already in the last 150 years of human history. But how much oil there is? We still have incredible amounts of oil. It all depends on the price at which we produce. So we have more OPEC and Middle East, other conventional oil, Arctic, deep water, super deep, enhanced oil recovery, heavy oil, oil shales. So there is plenty of oil. Oil is not the problem. It is just the cost. Depending on how much or how cheap it is, we produce more or less. In fact, we are now going deeper and deeper and deeper. Some of the most incredible wells today are offshore Brazil, really incredible. In Brazil, they go in the Atlantic coast, they go 3 kilometers into the water, then they do 2 kilometers under the ground, below the water, and then 3 kilometers horizontally. It's really incredible. 3 kilometers, 2 kilometers more, and then 3 kilometers. And they are like L wells. So technology has improved substantially in the last few years. So actually we still have a lot of oil, and we don't know which is the limit, or if there is a limit, because as the Sheikh Ahmed Yamani said in the year 2000, the Stone Age did not end because of lack of stones. And now the oil age will not end because of lack of oil. There is plenty of oil in the world. Every time we discover more oil in different places. I used to work a long time for a French company searching for oil around the world called Schlumberger. Schlumberger finds oil in many parts of the world. And there is plenty of oil. This reminds me of the wells. When we used the wells for oil, you know, the wells were worried that there would be a point where everybody would kill the wells for their oil. But that obviously has not happened. One serious consideration actually is global warming, as you probably have heard. And in a few weeks, we will have the COP21 conference in Paris to talk about this. But also that doesn't really worry me. And I think this is also the Russian position, that this is not truly the end of the world. And a bit of a warmer climate would be fantastic here in Russia. So, also because if we go back in time, you know, every 120,000 years there is a cycle, which also coincides with the glaciations. So we are now at the end of a new cycle. So actually, we don't know if the temperature will actually increase a bit more, but otherwise it should begin declining, because we are going to enter a new ice age soon. Soon could be 10 years, 100 years, or 1,000 years, or even 10,000 years. But we are supposed to enter a new ice age. Also, there is a lot of evidence that the global warming might be caused by the sun, because there has been an increased amount of solar radiation in the last decade. And so it could be actually because of solar activity. One thing that I discovered, which was to me very incredible, is the Inca mummies. They are discovering in the Andes, you know, the Andes mountains in South America. The Incas buried virgins that were mummified after losing their virginity in the top of the mountains. And they were lost for 600 years. Why were they lost? Why didn't anyone know that there were mummies there? Because there was a glaciation and the top of the mountains were covered. Now that the Andes are losing all the snow, the scientists are discovering the mummies. What I want to say is that 600 years ago, there was no ice on the Andes mountains. So when people talk about all the global warming, well, the world was very warm at the time of the Incas. There was no snow in the Andes mountains. Nowhere in South America there was snow. And that is why they discover now these mummies. But this is a proof that there is global warming. Okay, you can see how bathing suits are becoming smaller and smaller because of the global warming. This is today. I have a few things in Spanish, but anyway, you can understand the pictures. I visited last year an incredible place that they are finishing to build in Abu Dhabi, which is called Masdar. Masdar means the source, the origin in Arabic. And this is the first totally solar development in Abu Dhabi. It's a city that is going to be completely solar with electric transportation, self-driving electric transportation, and only using solar energy to power the whole city outside Abu Dhabi. This is an incredible thing for the Arabs to do because they have so much oil, right? But they also have a lot of sunshine. So even if they don't use oil anymore, they have lots of sunshine to use. Even this in Egypt, as you can see, they are putting a lot of solar panels outside the pyramids in Egypt. There is an exponential increase in the capacity of solar power around the planet if you go anywhere. There is also some interesting recent studies like this one done a few months ago, saying that solar will dominate world energy supply in just 15 years. What was very interesting that they calculated at which price oil has to go down to stop the increase of solar power. Because if you remember last year, oil was at $140 per barrel. Now it's at about 44. They computed that at the exponential increase of solar panels in production and the exponential reduction of cost of solar panels, even if oil falls to $5, they have no future in 2 years. Oil will have no future even at $5. In 2 years? In 2 years. This was a study done for Abu Dhabi. So think about it, $5 in 2 years. Obviously, that was for the amount of sunshine that they have in Abu Dhabi. In Russia, it is not so sunny. But the thing is that they will flood the world with solar panels in the places where they are appropriate. Okay, again, if you compare different types of energies, there is a price range. In terms of electricity, this is to produce electricity. As you know, electricity is sold in cents per kilowatt hour. And so solar at large scale utility level will get between 4 and 7 cents per kilowatt hour. Does anyone know how much electricity costs in Russia?
It's different for physical institutions.
That's right. Yeah, in the USA, the same. They have 3 prices: industrial, residential. But how much? Normally? 5 cents. Okay. So which is very cheap, because in the USA it's about 15 cents per kilowatt hour. But obviously you have a lot of energy in Russia of all kinds: nuclear, coal, petroleum. But even so, once we begin to think about wind energy, solar energy, will compete with some other sources of energy. Okay, what is very interesting is that the API, I don't know if you know what this is. This is the American Petroleum Institute that gathers all the oil companies in the USA. For the first time in history, talked about solar energy because they feel threatened. So they see in the American Petroleum Institute that solar is coming. And they are very worried because people are beginning to say that fossil fuels will remain fossil in 20 years. Fossil fuels will remain fossil. So all companies are going into solar. Edison is the company of Southern California. They created Edison for solar power. Many companies are moving also into energy storage, because the problem with solar energy or with wind energy is the variability. And you need to compensate that variability with batteries. And you might have seen that Tesla Motors, the company that is making electric cars, also is beginning to make batteries for storage that will be competitive together with solar energy and wind energy against natural gas and coal. Well, the California Republic, the state of California, had announced 10 years ago, when Arnold Schwarzenegger was governor, he set a target of 33% renewable energy by 2020. Right now, they are already at 30%. So the new governor, Jerry Brown, has increased that amount to 50% renewable electricity. Electricity is not the whole energy matrix. But 50% electricity should be renewable by 2020. This is only in 5 years. Half of the electricity will be renewable in California. No petroleum, no gas, no coal.
No nuclear?
Actually, no new nuclear. Yeah, because they have a few nuclear reactors in California. Germany also, I guess many of you are familiar with the Energiewende, energy transition in Germany, which is a program of the Chancellor Merkel, Angela Merkel, that also they want to get over 50% renewables by 2030. And this is moving very fast and is quite interesting because Germany also doesn't have a lot of sunshine. But still they are producing about a quarter of total electricity capacity from sun power today. And again, Germany is not sunny. Yeah, exactly. They are using more wind because there is much more wind than sun in Germany. And also in the Scandinavian countries, there are two incredible examples. Sweden has said that by 2020, they will no longer use any fossil fuels. And Iceland is already powering the island of Iceland with geothermal power because, you know, Iceland is a volcano, really. So there is a lot of geothermal energy. So those two Scandinavian countries already said goodbye to oil completely. Even small Costa Rica. Costa Rica said that they are already using 100% renewable for the first days of this year. So even Texas, this is a very interesting example because Texas is the oil state in the USA. They are really going 100% solar and wind because it is cheaper and more reliable. So how much renewable energy do we have? As you can see, the global consumption of energy on planet Earth is 15 terawatts. This is actually power, but you know they are related by unit of time. So we consume 15 terawatts, which is the elephant in the room. The elephant in the room is solar power. Thousands of times more solar power than we consume. The problem is that we did not have the technology to capture this solar power before, but now we do. If you want to see another chart, these are all from Wikipedia. If you want to check also compared to the fossil fuels, this is the amount of fossil fuels we have: coal, uranium, petroleum, natural gas, versus the elephant in the room, which is solar power, which is much, much bigger than anything else. And what is happening now is that we are getting to what is called grid parity, when solar power is becoming cheaper than fossil fuels. This is the death of fossil fuels, because fossil fuels, as I mentioned, even if they get to $5, they will not be able to compete with solar power. Everything is getting connected. For this, we also need electricity. Actually, we will have wireless electricity transmission to connect everything. This is the Internet of Things. You know, we will connect the cars to the computers, to the refrigerators, to your brain in the next 20 years. And you are certainly familiar with the self-driving Google cars. Let me show you the third generation of the self-driving Google cars. I was in one of these 2 months ago in California. You can see these cars actually no longer have a driving wheel. No driving wheel. But when I get inside, I really got scared because there is no brake and there is no accelerator. There is nothing. It is a computer on 4 wheels. Those are the cars of the future. You are part of the last human generation that drives. And thanks God, even though she does not exist, because we are very bad driving. We are very bad driving. We kill over 1 million people every year on accidents because we are bad drivers. This will not happen in the future. Thanks to the self-driving cars, all companies are announcing their plans. You know, Nissan actually plans to beat Google with their cars, and Uber, you know what is Uber, right? Uber now is actually working on self-driving taxis because they don't even want to have humans driving. Humans are not reliable. BMW announced that by 2025, at the latest, all of their cars will be self-driving and electric. And this is the baby, the Tesla. Actually, these cars are incredible, absolutely incredible. I have driven in several of them, and the Tesla is the end of gasoline. Why? Because if you look at the price, now that there are different kinds of Tesla, the Tesla Model X is already becoming cheaper and cheaper. And they will be charged for free forever at superchargers. These superchargers, Tesla has created a network of superchargers in the USA where each supercharger is 100 kilometers away from each other. Even though the autonomy, the amount that they can drive, is about 300 kilometers. But so that people feel okay, every 100 kilometers they are putting a supercharger. These superchargers use solar panels to charge the batteries that charge the car for free. For free. I want you to understand that word, free. Do you think gasoline can compete with something free? No. Even now in the USA, Walmart is putting also chargers for people with electric cars, so that people go and buy in Walmart and charge their car for free. This is the end of the petroleum industry. Petroleum cannot compete with free electricity. Cannot compete. Impossible.
Yeah. But depending on the difference in price. Then you can buy a car for $10,000 or $350, the difference in price.
Exactly.
Yeah,
But yeah, but then that is why the third generation of Teslas that come next year are going to cost $30,000. And the Chinese, the first generation was $120,000. Yeah. The second generation was $60,000. And the third...
80, not 60. You know, they say it's going to be 40.
It's not that much of a difference in the grand scheme of things, I don't think.
Yeah, well, the trend is clear, but yeah, it also depends on if you had a little bit of extra battery or something else. But the third generation, they are expected to hit $30,000. But anyway, actually, we have to worry more about the Chinese. The Chinese, there are 3 companies planning to bring electric cars next year to the market for around $20,000. So it's not Tesla, it's the Chinese that are coming.
I just have one question. Do they have SUVs? Do they have electric SUVs? Because
Yes.
Tesla, they all these, coupes and luxury cars, I want an SUV.
Yes, this is just beginning. There are very few models of electric cars yet, and they are beginning with the most expensive.
They recently put Tesla X, is called the Tesla SUV.
Yes, so they do, but the point again about charging for free is what I find interesting. They guarantee that forever you can always charge for free your car in the supercharging stations. Anyway, so this was the original network. Now it has almost 1,000 stations across the USA, and they are beginning in Europe, and next year they are beginning in China. Eventually, all the electric car manufacturers will consolidate this. It is not just Tesla. Well, it is now just Tesla, but then they will cooperate with other companies. all car companies are beginning to do electric cars. And the most incredible thing, which I visited also recently, is the Gigafactory. Tesla is creating the biggest battery factory in the planet. That factory that is going to be powered by solar energy and windmills, all the energy will be free when this obviously depreciates, because the windmills will continue running just like the solar panels. That single factory will double the production of batteries of planet Earth. You heard it well. This factory will double the production of all the batteries in the planet. And the Chinese said a few weeks ago, they said, oh, that Gigafactory, we are going to build 4 like that in China. So I hope that you understand what is happening with batteries, which was the only problem for not moving into solar and wind.
But is there enough raw material to
Yes,
do more?
yes. Because the technology is changing constantly, and the materials, even lithium, there is plenty of lithium in many places, but there are also cheaper materials that will be developed eventually. Yes, so do not worry about the materials. So this is the BYD. This is the Chinese company Build Your Dream, making electric cars that say that they are going to build several gigafactories of the type of Tesla. So when the Chinese move forward, you know they are for real. Okay, many countries are using all of that. I want to show you, because some people think it is impossible to do this transition that will happen in the next 20 years. For those of you who don't believe it, look at New York. In the year 1900, on the Fifth Avenue, there was only one car. Everything else was horses. Horses. If you look at New York, in 1913, everything was cars except for one horse. This happened, look at it, in 13 years. So the same will happen in the next 20 years. All the cars, probably in 5 to 10 years, all the new cars will be electric and they will be self-driving. Okay, so if you look at how these technologies are changing, I'll give you just two numbers. An oil engine has an efficiency of 15 to 20%. That's in Spanish, but anyway. 15 to 20% is the efficiency that a gasoline car has, converting the gasoline into movement. An electric car has an efficiency of 85 to 90%. It is impossible that a gasoline car will be able to compete with the most efficient electric cars that we will have. Okay, so where are we in a table of energy content if we compare different type of fuels? We have basically been in the order of fossil fuels between 10 and 50 megajoules per kilogram. Even higher it's dams, water, hydroelectric power. If we have 1 kilogram of water, 100 meters, that has 0.001 megajoules. But talking about fossil fuels, we're in the range of 30, 40 megajoules per kilogram. But we have additionally incredible sources of energy that we have not used yet. We have obviously mass energy equivalence and the ultimate form of energy, antimatter, transforming or crashing antimatter with matter, as you have probably seen in some science fiction movies. So look at how much energy we will be able to gather in the future once we advance technologically. Additionally, we have plenty of bioenergy that I call eternal energy because it's the energy of life, photosynthesis, and now scientists are working on artificial photosynthesis. It's very simple. You know, it's CO2 plus water plus light gives you carbohydrates, which is the same as hydrocarbons, more or less, plus oxygen plus water. So photosynthesis is what will let us go from fossil fuels, fossil hydrocarbons, into live carbohydrates. And then Craig Venter, who sequenced the human genome, he's also working on bacteria for producing gasoline. This hasn't worked yet, but it is a possibility in the future if you want to use liquid fuels, because we do need liquid fuels for some forms of transportation, like airplanes. For airplanes, we need now liquid fuels. You cannot put a battery that big. Okay, so there is also nuclear fusion, not fission, but fusion. There are two major experiments in the world. The National Ignition Facility in the USA that uses lasers to fuse hydrogen into helium. And there is a European project, ITER, in southern France, which is $30 billion, to use a tokamak, like some were done here in Russia, but this is an international project. Anyway, so these two are possible forms of fusion energy in the next 20 years. They have a development plan and so on and so forth. Anyway, some people are talking about the Internet, which is the energy internet, where we are going to move from dirty energy to clean energy, from a stupid grid to an intelligent grid, and so on and so forth. So we are seeing truly a big change in how energy is being produced and consumed and how we will be connected. Buckminster Fuller, a very famous futurist in the USA, he talked about this idea and a global energy network institute. This is just beginning, wiretricity, wireless electricity. We will no longer be using cables in 10 years. We don't need cables to transfer electricity. Just like we don't need cables for mobile telephones, we don't need cables for electricity transmission. So this is called wireless electricity. Wireless electricity. There are two competing platforms working on wireless electricity. And we will actually have very efficient energy systems with almost zero power consumption. But this is one of the two systems competing, which is called wireless power. This is a consortium of eight companies of how we are going to be using wiretricity, wireless electricity, to recharge smartphones, automobiles, even for applications in restaurants, hotels, and so on and so forth. Let me go back to how much land do we need for solar power. If we had 6 blocks of 100 by 100 kilometers, that would produce all of the energy, electricity plus transportation plus everything, all of the energy that humanity uses today. Only 6 blocks of 100 by 100. Russia is the biggest planet on Earth. 100 by 100. Yeah, 100. Oh, okay, yeah. No, it's 100 by 100. Yeah, this is. Yes, right. Good point. Yeah. This is 100 by 100 kilometers. But anyway, my point is, Russia, even though I know there is not a lot of sunshine here, but Russia has incredible amounts of land. And then remember, we will have also wireless energy transmission. Wireless energy transmission. NASA, actually in the year 2002, they had a plan for technological demonstrations of wireless energy transmission. And as you probably know, the International Space Station uses solar panels. They don't use oil. They don't use nuclear energy. They don't use coal. They use solar energy. Japan, after the Fukushima Daiichi accident, is accelerating their program of 2030 space solar power. They plan to begin powering Tokyo with space solar power. Okay, these are the Japanese. If this were, I don't know. Yeah, Venezuela, an unreliable country, whatever. Kenya, I don't know. But this is Japan. Japan more or less fulfills what they say, and they are very advanced on wireless energy transmission from space. This will be something like that, solar panels sending. There are two competing systems also. You can do it with lasers or with microwaves. The two technologies are viable, but scientists are working which one will be cheaper in the long term. Also, if you don't want to put the solar panels on planet Earth, you can put it on the moon, and the moon could produce over 20 terawatts of power and send it to Earth. The moon is relatively close, and there is not much filtering of energy from the moon to the Earth. So I created the word energularity because Ray Kurzweil popularized the idea of the technological singularity. Aubrey de Grey, the idea of the Methuselarity, which is live long enough to live forever in the next 30 years. If you do not die in the next 30 years, probably you will become almost immortal. That's the idea of the Methuselarity. And so I invented the word energularity. And the idea of the energularity is actually based on a Russian physicist, which is one of the most incredible physicists with these ideas. His name is Nikola Kardashev. Kardashev, who is still alive, even though he's 85. Nikola Kardashev, 50 years ago, he created the energy scale of the universe. And he computed how much energy we receive on planet Earth from the sun, and how much energy does the sun produce, and how much energy does the galaxy, the Milky Way, produce, and how much energy is produced in the whole universe. I'll give you some quick numbers. For example, a CD-ROM, well, they do not exist anymore. No one uses CD-ROM, but it is 5 milliwatts. A wristwatch, a quartz wristwatch, is 1 microwatt. A human brain, this is interesting, a human brain is 30 watts. Your brains are machines of 30 watts. A mobile phone is about 5 watts. A laptop is about 30 watts. A light bulbs normally are 70, 80, 100, 120 watts. The human body is 100 watts, even though there are some that are maybe 120. But on average, we humans are machines of 100 watts, and our brains are 30 watts. The brain is 30% of the energy consumption of a human being. Okay, so Nikola Kardashev computed that the whole planet Earth receives, here it is, total power received by the Earth from the Sun. That would make us civilization type 1. That is 174 petawatts, which is 10 to the 15 watts. That is the amount of energy that we receive freely, daily, continuously from the Sun. And how much energy do we use? Okay, today we are actually in the order of 15 terawatts. This was before. So now we consume 15 terawatts, but we receive 174 petawatts. So does anyone think that there is energy scarcity? Energy is so abundant, and this is just to be civilization type 2. To be civilization type 2, from 1 to 2, is that we capture all the energy produced by the Sun. Civilization type 3, all the energy produced in the galaxy. Civilization type 4, all the energy in a supercluster of galaxies. And civilization type 5, all the energy of the universe. And how much energy there is in the universe? A lot of energy. Okay, so there is no scarcity of energy. What we have is a scarcity of imagination. So anyway, Nikola Kardashev gave me this idea that when we reach civilization type 1, we will have reached the energularity. So the energularity is the time when we reach civilization type 1, according to Nikola Kardashev. So, and this is unstoppable. Solar energy will keep on going down, down, and down. And with the difference is that once the solar panels are installed, there is no fuel. So fossil fuels cannot compete with something that is free. Because after solar panels or windmills depreciate, they are free. You don't need to buy gasoline. You don't need to buy coal. You don't need to buy uranium for a reactor. You don't need to buy any fuels. Solar power is growing exponentially while the prices, the costs are being reduced exponentially. One professor at MIT, my alma mater, he computed that if we look at the cumulative production in gigawatts peak, how much have we produced and how much has the price gone down? We have actually produced relatively very little in number of solar panels. And however, the price is already at the planetary level is around 12. We are around 12 cents per kilowatt hour. Also, the efficiency of the solar panels continue increasing, and this will continue increasing more and more. That is the global energy flux matrix, and the same energy used in the USA, which is also very important. If you look, energy rejected, about 60% of the energy produced is wasted. This is incredibly bad. 60% of all the energy that produced in the USA, I don't know the numbers for Russia, it would be interesting to check, but in the USA, which is supposedly an efficient country, 60% of the energy produced is wasted. And most of it, you can see, actually comes from coal. Coal is one of the worst. and for electric generation. And the other one is for transportation here. And here we are going to be using electric cars in the future. So what will happen is that when we move into electric cars, the consumption of electricity will actually decrease, not augment, not increase. It will decrease because cars, electric cars, are much more efficient than gasoline cars. So the total amount of energy will go down, not up, with electric cars. This is something to think about. What we will see in the next 10 years when all cars are electric, new cars. Okay, another interesting thing is that there is a decoupling, separation between energy use from economic activity. We use every time less and less energy to produce more and more wealth. All of energies, renewable energies, are going down exponentially. All of them, photovoltaic, concentrated solar power, wind, even biofuels and geothermal. Okay, this is very interesting. What is happening with energy storage? What are the trends today? How fast is energy storage going to grow in the next few years? And there are also many types of for your question about batteries, if there are enough materials. Scientists are working on all the possible combinations. And something which is very interesting for making new batteries is that now robots are making the experiments. Robots can think faster than we do, can make different combinations possible. So now this is being automatized. And we will have incredibly efficient batteries done by robots. So there is a huge matrix of different possibilities for batteries. And there are other ways to storage energy. This is being done in Belgium, where they are creating these like little floating islands where you actually can control the elevation of water for storage and for energy production later on. One of many other interesting examples, and this is offshore Belgium. So we will have even solar camels in the future. We will also have solar donkeys in the future. Everything will be solar. You will recharge your donkey, your camel with solar power. And we are moving to a world of cheap energy. We are going to see in the next 20 years the end of energy poverty. And this is the famous NASA picture of the world at night that you have probably seen. Which I love because the Chinese say we need to light up the world. The Chinese have fantastic phrases for everything. And they say, do not blame darkness. It is better to light up a candle. So let's light up a candle instead of blame darkness. But in this map, you can probably see Korea. And there are two Koreas. I actually went to North Korea over a year ago. And this is true. There is no electricity in North Korea. It really is horrible. While South Korea is incredibly illuminated, Seoul is one of the 5 largest cities in the planet, completely illuminated, with the best internet in Asia, South Korea. While North Korea is the last country in the planet still without internet. The last country in the planet without internet. While South Korea is incredible, internet. So, look at this, also how illumination changes with technology. This is the Pope in 2005, and this is the latest Pope, Francisco, in 2013. Or Shanghai, the incredible development of Shanghai in the last few years. So I want to finish that we need to think about, like the Chinese, that everything has its yin and yang. The dark side of the force. And inside yin yang has little more yin yang, so this is very complex, and inside even more yin yang. So we have to meditate about the future. I love meditating with my Hindu friends, my Buddhist friends, and so on and so forth. And I finish with this Chinese word. I lived 3 years in Tokyo, and I had to learn Chinese characters. This is one of the most beautiful Japanese characters that comes from Chinese, and the Koreans also use them, and the Vietnamese. So this Chinese word means crisis, crisis. Before I used to draw it upside down or sideways. Now I know it is written like that. This means crisis, and it has two characters. The first character is danger, but the second character is opportunity. So we are living in incredible times. We are going through a global crisis, especially in energy, with a lot of danger, but a lot of opportunity. So, thank you very much.
Well, actually, my name is Alexei, the Libertarian Party. My question is actually about the scope of government intervention into these technologies. I know that in the United States, things like solar power are aided by government, are subsidized in different ways by the government. And still, I have not yet seen a viable or a competitive product that I could buy from Tesla or something like that. I have not seen, well, they make cars, but I haven't yet seen something I would like to buy and could afford. So my question is, what is actually the amount of government intervention into these technologies and the development of these technologies? And what if we, presumably, let's presume we have a level field. What would the situation be on a level field with no government intervention? Would oil still be gasoline, old good petroleum and combustion engines? Would they still live a couple of years more?
Yeah, well, this is an excellent question because government intervenes in many ways. Intervenes with taxes, with subsidies, with regulations. And we live in a very imperfect world. So it is true that there are some subsidies in the USA to some of these solar technologies and to electric cars. But it is also true that there is an even higher subsidy to coal and to petroleum in the USA, which is many times bigger than the subsidies to solar power. The numbers are incredible. If you look at the International Energy Agency, they estimate that the subsidies to the fossil fuel industry is about $20 trillion in the next 5 years. It's an amount difficult to understand. Anyway, the point is that we don't know because there are many government interventions, but what I can tell you is that the Chinese are beginning to sell solar panels and electric cars, and they are not stupid, and they are not doing it to lose money. So I think these products have really become very, very competitive. And as I showed in some charts, today both wind power onshore and solar power in large quantities is reaching 5 cents per kilowatt hour, which is cheaper than coal today. But again, yeah, it's a complex thing. It's not easy answer because the government intervenes and screws up things in many ways.
Hi, my name's Nikola. Nice presentation, it was great. My question is related to your first presentation. I have the feeling that there is lack of debate about the ethics and morality about the technologies you described in your first presentation. Not to get me wrong, I consider myself to be progressive type. I acknowledge that the humanity should use the benefit of the progressive technologies, but as you mentioned, we are the last generation by mistake. So after that, we will get rid of the natural selection, right? In a way.
Yes.
And I'm afraid that there is a lack of debate about the morality and the ethics, because in my opinion, and what the history has shown in the past, that all these technologies, especially the advanced technologies, are first developed for military purposes, so they can be misused, and then for civil purposes. But I'm afraid that until today we had the chance to redo our mistakes in the history. So we come up with something and we use it for military purposes, and then we go back and redo our mistake. But this time I'm afraid that if we do the mistake this time, in the future, we won't have the chance to redo it.
Yes, yeah, these questions are very important. At Singularity University, and Anna Trunina, who is there, she was in the summer program, we have a class called Policy, Law, and Ethics, because policy, law, and ethics is fundamental, because these technologies will not only change humanity, but as I said, will change humans. You are going to be changed. I am going to be changed by these technologies. So the political, legal, ethical implications are absolutely incredible. It is even more dramatic, as I said. We are going to see the end of the human age and the beginning of the post-human age of enhanced humans for those humans who want to evolve. I also mentioned that we are 99% equal to the chimpanzee, right? So we are almost chimpanzees, but that 1% in the genome between a chimpanzee and us made an incredible change. Okay, so now we are going to have something even more radical. But my worry is that part of humanity will stay behind. I'll give you an example. Probably all of you know the Amish. The Amish, who is a religious sect in Pennsylvania in the USA. The Amish left Europe, a religious sect in the fundamentalist sect in the 18th century. And they took the technologies they had up to the 18th century, moved to the USA, and then stopped any technological development. So they do not have cars, they don't have electricity, they don't have mobile phones. They decided to do that. So part of humanity will probably decide to stay behind and not use technology. I would hope that most of humanity would move forward, but we don't know. Maybe there will be people like chimpanzees who will stay behind. It's very complex, very difficult.
The main point is, do we have the laws and everything that will guarantee us that this progress will be positive for the humanity, but not negative? Do we have this?
Yeah, well, if it is good or bad, it is not because of technology, it's because of us. We humans, we are not that ethical, we are not that moral. The fact is that this is an incredibly wealthy planet, but there are wars, there is poverty, there is hunger. So there are no reasons for those things in this wealthy world. So the problem is not the technology, it's humans. So also a related question that people ask me, do we have to be afraid of artificial intelligence? And I say, no, of course not. Do you want to be more intelligent or less intelligent? The problem is not artificial intelligence. The problem is human stupidity. And we humans are very stupid. Therefore, we should strive to be more intelligent. And if we cannot do it naturally, then we should do it artificially. We can advance civilization with more intelligence. Therefore, we need to have more intelligence, not less intelligence.
More questions?
Or also,
I would just like to make a comment that laws cannot guarantee anything. I mean, it's just impossible. And I mean, even if laws are mandated to limit this technology in any way, there's still be people who would see the potential and maybe just develop it underground. So it wouldn't stop the progress, I don't think.
yeah, I agree with you on that, because if someone wanted to regulate designer babies or how we will design our children, some people will do what they want anyway, because if they want to have taller children or smarter children, they will find a way to do it, okay? Even in China, as you probably know, 2 weeks ago they eliminated the one-child policy. But people who wanted to have 2 children, they could still find ways to do it in China. So obviously you cannot control, you cannot regulate everything. And anyway, that doesn't guarantee it is good. It could be bad. Like the subsidies to the fossil fuel industry, which are really big and they are not good. Okay, so yeah, I don't believe too much in government intervention either for many of those things. So any other comments, questions? Tomatoes or rotten eggs?
Well, I actually wanted also to comment on the subject that you touched, the subject of staying behind. I mean, do we know enough about humans to know if they will wish this, if they will want to intellectually develop? Because humans, they desire strange things, they desire irrational things, they do strange things, they commit suicides, they take drugs, they do all kinds of stuff. This is actually a pretty interesting subject.
As I said before, that is why I'm not worried about artificial intelligence. I am worried about human stupidity. We should increase the overall level of intelligence of humanity, and also individual by individual. I think it would be fantastic. And if you don't do it here, someone else will, like the Chinese. You know, the Chinese have many programs for increasing the national intelligence of the Chinese. They are sequencing the genomes of the most intelligent Chinese to try to find some genes that make you intelligent. And then try to replicate this in all the Chinese people in the future. So we live in interesting times, very interesting times. So, yeah, Greg?
Well, so at that point, I have to say many thanks to Hosse and the tradition, like little gifts from Moscow Technological Institute. And
Thank you.
Moscow Institute of Physics and Technology. I believe it was very interesting, and especially I hope that our students at systems engineering will take into account, many interesting points and predictions out of the presentation, in order to then you will build your strategies about, development of the systems. You will think about how it's changing very fast, everything around, right? So, and thank you very much.
A pleasure, a pleasure.
And let's actually try to see what happened during.
Okay.
Can you show what actually how it was during the presentation?
Yeah, can you tell us the results here? The analysis of the results here, of their concentration. Here for the winners also, what does this mean?
Allows.
We can show you the slides which were mainly interesting for the audience.
Okay.
So
Fine. Then.
can you show those slides?
The maximum number of slides, right?
Yeah.
Number
Left.
The slide number, the most interesting slides, and least interesting,
Most interesting.
and least interesting. No.
They are only interesting as
Okay, we'll send you via email all the results of your presentation.
Wonderful.
Okay. I think you can socialize a little bit.
Yes, of course.
You can come to Hosse and ask questions.
Yeah.
So, Mr. Cordeiro, regarding tomorrow, I mainly want to talk to you about tomorrow morning, since we will be meeting you in the morning. And I'm thinking about a lunch. Maybe I could come up to your hotel lobby at a set time, and then we'll just meet and just go to a nice place nearby. How about that? And then you could return to your hotel and just go about the rest of your day, including your meeting with Alexei and some of the rest of our people as well.
Yeah. The thing is that my agenda changed.
What's your agenda?
They are going to pick me up from Skolkovo Foundation at 10 a.m. from the hotel. So maybe we can, I don't know if it is too early, but we could meet at 8 o'clock or something.
So, do you mean at 8 o'clock in the morning, right?
Yeah, because they pick me up at 10 a.m. and then I'm going to be out all day.
Right.
Or the other possibility is on the evening.
Right, I mean, there's
1 second.
Yeah.
Photo with,
Yeah. Okay. Here, let's meet.
Тут в два ряда надо, наверное. В два ряда. Давай.
Может, кто-то сядет? Пара
Да ладно. Не страшно.
Good. Thank you.
So for now, I'm thinking that maybe it'll be best for you and for you to be able to just get some sleep. For us to meet in the evening during the general meeting with some of the other members in the party, right?
Some other members expressed their interest in meeting you. So I believe your conference ends around 6 o'clock in the evening.
Yes, the 3 days, because but on Thursday we have a dinner, so that I have to go to the dinner right after. But tomorrow and Friday, I should be finishing at 6:30 at the latest. So tomorrow would be fantastic.
Okay, so we'll just go to some cafe around there.
We'll figure it out. We'll let you know.
Okay.
Certainly.
I'll have Wi-Fi all day in the afternoon.
So your best to be reached on Facebook, right? It's best to reach you on Facebook.
Yeah.